5. We're on this page, and we're at the bottom here on the example 1. All right, so now we're actually, with all of our algebra skills, we're going to prove an identity. So the instructions for this are prove. Okay, prove. Some of them say that it's true for all real x. Some of them just say prove. When I say to prove, I mean for all x, right? So that just means prove that this is true. What are you trying to prove? What are you trying to prove? You're trying to prove that this equals this. You're trying to prove that sine squared minus cos squared equals 2 sine squared minus 1, using only the identities I gave you. So don't look up any more on the line and try to say, okay, but I found a couple other ones that make it. No, just using the ones I've let you use, which is the Pythagorean, the reciprocal, the tan, and the cotangent and stuff, right? So just the ones that we learned. Using only those, we should be able to prove that this is true. The way that you prove that this is true, very, very, very important, is the first step is that you have to say, I want to prove that the left side equals the right side. So I want you to grab the left side and write it down. You're not going to want to do this. I'm making you. Grab the left side from my original question, and I want you to take the right side and write them down. So copy my question. Copy my question down. So what you're doing is you're going to prove that my original question, so I need to see this step. Okay, it's a bit picky, but we're making you write that down. Okay. I need to see that step where you're copying it down to say that I'm going to prove that the original statement that I gave you from my typed out question is true. Because some people do this completely wrong, and you are not allowed to do this. Not. Some people go, can I just bring this over and collect like terms like you said I could collect like terms? You cannot. As soon as you bring anything from the left to the right or the right to the left, you're assuming that this left and right equal each other, right? By bringing things to the left and right, you're assuming it's true. I'm telling you, I don't know if this is true. And in the past, we have sometimes given you ones where it's not true, that this does not actually equal this. So when you take the left side and you take the right side and you try to make them match, they will never match. So you cannot bring anything from the left and right, because if you bring anything from the right to the left or left to the right, you're assuming it is true. That's your first assumption. So you cannot assume. You have to take the original question given, say I'm taking the original left and original right, and I'm going to make them equal each other at the end. So the goal is to make sure that they equal each other. So I want this one to actually equal this one and this one to equal this without touching. Without touching. If you put the equals in the middle, I'm not marking it. Just not going to mark it because you've ignored the exact first statement of what I just said. If you put the equals between these two and put it all, you're proving that the left side, you've now said that they equal each other. The first step is to say, I want to prove them separately. It's like me taking you to one room and saying, yeah, what's your story? What's your story? Are you really? What am I checking? And I can look at the other person and go, okay, so you should equal that, are you? And I'm going to make this one equal this side. Or I can take this side and say, oh, are you actually? And I'm going to cheat and look at the other side. But I want you to do this independently of each other, okay, without bringing anything left to over right. So do not put the equals in the middle, and do not simplify it first. All right, so here, now compare. You're allowed to cheat. So some of your homework question, they don't give you the right side or the left side. They just give you one side and they say simplify, which means they want you to practice the algebra. Sub in, collect like terms, get it as simple as possible. When we give you the left and the right, it's actually super good because you can totally cheat. And you're not cheating. Compare. I want this to equal this. I want this to equal this. Which side is kind of simpler to look at? Kind of more simple, like less there to work with. This one, it's only got sine squared. This one has two variables, right? This one has one variable. This one has only sines. This one has sines and coses. So what I'm going to do is I'm going to convert this one to all sines. How can I do that? Because this has a squared. It's a cos squared, and we just talked about that. I can change cos squared to, so I'm going to write this down. So keep this one, minus, and cos squared is, cos squared is 1 minus sine squared. Is that true? We just did that above, right? Cos squared is 1 minus sine squared. Now, all I need to do is bring in and collect like terms. So keep going. So it's all algebra. So it's just sine squared minus 1 plus sine squared. Are you okay with that? Just brought in the negative 1. And what do you see? What did I ask you to look for? Like terms? Yeah, and then how many are there? 2, and keep cheating. It's not cheating. If I give you the other side, please look. I'm telling you to look. You know the goal. The goal is to make it look. I have 2 of them? Yes, I do. Do I want a minus 1? Yes, I do. You're going to know when you're done. Everyone always says, what's the answer? Well, I'll show you in a second. Hold on. So 2 sine squared minus 1, are they the same? Are they identical? Does left side equal right side? Then you're going to say, therefore, left side equals right side. Done. We used to put QED. QED was, again, I'm 9,000 years old, though. So QED was Latin for quadratum demonstratum, that which was to be demonstrated. Or a little box. You can say that was what should be demonstrated, but I think we just put left side equals right side now. So we would be like, QED, QED. I think it's in a movie somewhere. I don't know. Yeah, old movie. I don't think anyone knows that anymore. It's Latin. So left side equals right side. That's your goal. So your goal is to get left side to equal right side. They have to be identical, and you stop when they become identical. You're done. Every single one of these, your goal is to make the left side equal to the right side using algebra. Substitution, elimination, lowest common, all that stuff. So all the skills we just talked about, that's our goal, is to get here. I'm going to try one more. Okay, so flip over. Let's do one more. Okay, just so you can get the feel of it, and then we'll continue next time. All right, ready? Okay, right here. Okay, so here I have my left side is 1. Okay, not much there. My right side is this thing. Okay, so I'm going to copy down the original. So my left side is 1. Left side's 1, not much happening there. I'm just going to leave it alone. Can't do much with that. My right side is where I'm going to start with. So right side equals. I am going to copy it out. I knew it's a pain, but it gives me like my title. Okay, so I have 4. So when I copy it down, I don't use that as wasted time. I analyze it while I'm copying it down. So always copy the original question. You have to copy the original question. Okay, so I write down the original question, have to. Again, right? Don't lose marks, this. And look, I separated left side and right side. Do not put the equals in the middle. I can't. Okay, that means you're not proving it. You left it in the middle. You're saying that they equal. I want you to prove that they're equal. So you have to separate it. Must be separate. Must be separate. Okay, the left side, right side. So left side, right side must be separate. Okay, you cannot leave them together. So the left side and the right side must be separate. Okay, so I took that, wrote down the questions, don't lose marks for that. Now, when I was writing it down, analyze it a bit. I have 1, so it should be very simple here. I have here sine to the 4, and I had 2 coses. I have more of the coses than I do of the sines. So how about we convert the sine to the cos? Do I have 2 of them? You're only allowed to use Pythagorean with 2. Doesn't work with 3s. No odd numbers. Do I have 2? Yeah, I have 2 2s. So I'm going to take this guy, and I have 2 of the sine squareds. I have 2 of the 2s. Okay? Then we just write down the rest. So keep this stuff here. We're just going to collect like terms after, but let's do this. So yeah, if you wanted to skip that step, you could. And what does sine squared convert to when you do it to cos squared? Only works with 2s. Only 2. So look, I'm just going to highlight. It only works with 2s. People try to do it with 1s. It doesn't work with 1s, right? Pythagorean identity is only, right? So think about it. Pythagorean theorem is a squared plus b squared equals c squared, right? It is not a plus b equals, you would never have done that with the poor triangle. Would you have done that with the poor triangle? No, right? It's not 1s. Squared, squared, squared. So here, sine squared is, so convert it. 1 minus cos squared. Does that make sense? Right, so we know the two of them can convert. That's our big, big, big one this year. Right? Again, next year we do more. We do more formulas and double. And you have to write the angle. So write the angle, please, please, please. I'm just going to note that down here. So write the angle. Sine theta, not just sine. Does that make sense? Because again, next year we're going to do double angles and half angle. You've got to have the angle there. Otherwise, we don't know what angle it is. Don't just write that. Does that make sense? Okay, so don't write it without. People, I know you're tired of writing it. So am I, but, you know, too bad. So here, then we keep this as is, and all we want to do is expand now. So expand this guy. 1 minus, it's a binomial squared, so 2 cos squared theta plus cos. Are you getting used to the binomial squared again? Right, so binomial squared is double in the middle, cos to the 4. I have this guy here. Okay, now what do I do? So close. You're so close. So close. Yep, what can we do though? What can we cancel? What can we, like terms, which ones? This one with that one, yep, and that becomes 0. See, is that the question I did before? I think I took that algebra from this one. This one. 0. What am I left with? What a shocker. Not a shocker. Not. What was my goal? 1. And therefore, left side equals right side. Please conclude. That's actually your concluding sentence. When you get there, it's super satisfying. When you get it, you're like, yes, that's a beautiful thing. So you should be proud of yourself. Okay, left side equals right side.